A little bit about me. I am an author. I wrote an exam prep book for an exam that's no longer in session. I'm a consultant. I do a lot with Power BI and data analytics. I'm also an instructor at Data Camp, the online training place that specializes in data science. And I'm a data platform MVP and a Microsoft certified trainer. All right. So today we want to basically talk about all the different data warehousing cloud products that there are, and then talk about some of the different methods and the tools that you can use for them. That's another consideration that you're going to want to think about. Some of these different tools require skills that you may need to acquire before you're going to be able to use them effectively. And all that information is designed to help you determine in your environment which product would be right for you. So if we're talking about modern data warehousing, the goals aren't really any different. People are still looking for data that's somewhat cleaned up. They generally want to use SQL to do some kind of reporting, or Power BI, which in the back end uses a data model that's using SQL. And people are looking for that single version of the truth, and they want it something that they can scale. So that part hasn't changed. But what you do want to think about when you're looking at which product is you want to look at these 5 things to kind of give you an idea what would be the best option for you. The first one is size. If you are looking for a database that's maybe a couple of petabytes in size, that limits where you probably want to go. If your database is never going to be much more than a couple terabytes, why pay for something that you're not really going to use? The skills of the people doing it. Just because Azure SQLDB has SQL in the name doesn't mean that it necessarily works the same way as, say, a SQLDB. So you need to make sure that you've got the skills in place to make it effective, because I have a friend of mine who walked into a client and they thought that Azure DW was a big giant pile because they had nobody that really understood it. They partitioned it incorrectly and it was extremely slow. So those kinds of things will influence your implementation. Then growth. What are you looking for in terms of growth? How much data? How much is it going to be growing over time? What types of analysis do you want to do with it? While you can, back-end any database into most modern analytic tools, some are better designed for that than others. And then, of course, price. Because if money is no object, you will, of course, pick very cool things, and let's face it, that's rarely the case. Another thing you're going to want to think about is your data warehousing architecture. You have this database. How are you going to get that data in it? SSIS, ADF, Spark, Kafka, Event Hubs, what? Is this data going to be streamed? How is the data going to be getting into the warehouse as well? Because if your data is coming from a stream source and you want that in your database, then there are products that are better suited than others. And these require different tools to be used. We're not really going to go into them. So for data warehousing in the cloud, we've got virtual machines. That's sort of a cheat, so I'm not going to talk about that. Azure SQLDB. As of Monday, Azure Synapse Analytics, which is included in SQLDB. I went and updated my slides this week after seeing some of the stuff that was talked about at Ignite. I'll tell you a little bit I know about it, and then show you where you can get more information. But it will impact things in the very near future, so I couldn't not talk about it. HDInsight, which is, of course, Hadoop. And Data Lake Gen 2 and how that can be used in a data warehousing-like environment. Cosmos DB, Snowflake, and Databricks Delta Lake. SQLDB, does provide the ability to create a data warehouse in the cloud. This is actually the easiest solution for a lot of people because it's very familiar. It works just like SQL does. So you're likely to have people on staff that have the skill level for it. You don't need any additional tools. And you can put databases in up to 100 terabytes. So it definitely can scale and do a lot for you. It's also relatively inexpensive. It can be cheaper than a VM. When I was talking to my client about where they should put their data warehouse, we ended up putting it in SQLDB. And they're very, very happy with that. It worked very well for them. The next place that you might want to consider is the SQL Data Warehouse. This is now called Azure SQL Pool when it's incorporated inside of Azure Synapse. But it's designed for databases 2 terabytes and larger. If your database isn't that big, don't bother, because there's a lot of overhead involved with it. It does handle streaming data, but it's also derived from Microsoft's big data product, APS. So you need to have a different background to be able to more efficiently structure it so that it'll work well for you. You need to understand partitioning. It's designed to integrate with Data Factory or Polybase, and like I said, there is some skill required to make this work well. So as of Monday, Microsoft announced Azure Synapse Analytics. And this is designed to be a product that allows Microsoft to compete better in some of the big data space. And it includes Azure SQL DW. It's funny, if you go to different pages, they call it different things. But I talked to somebody about it yesterday. And what Synapse Analytics provides is a lot of different ways to have your data incorporated so that you can use it for a data warehouse. It now includes a Spark, native Spark cluster, and it integrates a number of different languages, so you could use C# or Python, Scala, or R with it. And it's really going to be completely changing the cloud data warehouse. It's in limited preview now. So if you want to go take a look at it for now and play around with it, it's free as long as you get approved to be in it. And if you are looking to make a decision in the next year, I'd probably look pretty hard at some of the features that are included in this to see if that influences your choice and where you wish to put a data warehouse. Yes. Well, it's designed for larger. Well, it's designed for larger data warehouses, but it's also designed for unstructured data because it also includes the ability to do Cosmos DB in it. It also includes the ability to do data lake analytics in it, and it also includes the ability to use Databricks Delta Lakes within it. So it's a big umbrella that encompasses a number of different parts. But it's not, it is a much different paradigm than just doing SQL because it handles so much more. So there is going to be some ramp up involved if you wish to go that route to be able to structure it in a way that would be meaningful. But it also can be blazingly fast because the compute is separate, completely separated from the data layer. So it will allow for really good scaling and scale up, scale down capabilities as well. So I'm looking forward next week to I'm playing around with the preview. I already signed up. So Data Lake Gen 2 is really designed to handle more of your unstructured data better. It's designed to be the data source for a number of different tools. And it is a improvement on Data Lake Gen 1 because it's now multimodal. And it has a hierarchical namespace. It's using the Azure Blob file system. So it's also relatively inexpensive to operate with. You're not going to get the kind of performance, though, with this because it's not a relational database. So it's very handy for people who want to go with a NoSQL thing, but it's not necessarily going to provide you the speed that you would need for that. So it does have, improved performance, and from a cost perspective, it's quite good. It handles massive scale. It's really improved the performance over standard blob storage because the hierarchical namespace acts as imaging, and it secures data at the file and the folder level. So it allows you to really have a very granular structure for your data. It integrates well with a number of ETL tools. It's optimized for both Spark and Hadoop, and it's relatively competitive. Now, if you're going to look for this, though, you're not going to find it in Azure because it's not a service. So you'll look around for it, and you'll be like, wait a minute, I see Azure, I see Azure Data Lake for Gen 1 because that is a service. It becomes Gen 2 when the hierarchical namespace is enabled. And one of the things that it also incorporates with is if you have a soft delete, meaning that you could go back in time if things are actually deleted. And you cannot have a hierarchical namespace, which makes it Gen 2, and that soft delete capability. So let's take a look at what it takes to actually create an Azure Data Lake Gen 2. So I am in Azure, and you can see my screen now. So I am going to go ahead and create a resource here. And I want storage, so hello. And you'll notice here is Azure Data Lake Gen 1 is here and Gen 2 is not. So I'm going to go ahead and create a new one. So go ahead and do storage account. All right, so I'm going to select an existing resource group. And then I'm going to select my instance details for this. This is relatively quick. To create. I can have either a standard or premium. Both of them will work for this. For storage, I would have general purpose V2 or V1 or Blob Storage. Blob Storage is inappropriate because it is just for images. I'm going to keep it on V2. I can, for replication, I can get read access geo-redundant storage. There are price points involved in these different levels, so you'll want to pick what is appropriate for you. Geo-redundant, of course, means you've got copies in multiple places. And if it's cool or hot dictates how quickly that you can restore your files. So I'm going to go ahead and say cool. I'm going to go ahead and create it as a public endpoint. And this is where we get into making it Gen 2. So I'm going to disable security transfer because I'm not going to need that. And it says based on what I've picked, I can't do Azure large files. I do not want Blob's soft delete, but I'm going to enable Data Lake Storage Gen 2. And that's how you know that this is what you were trying to create. So only when you get to the very end do you see the fact that this is Azure Data Lake Gen 2. And I'm not going to tag my stuff. And I'm just going to go ahead and say create. My validation passed. And so one of the things that is a common tool, if you haven't downloaded it, you should. It's free to be able to access items to upload items to your data lake for initial testing. Was, of course, the Azure Storage Explorer. It used to be that people used a non-Microsoft tool for this, but Microsoft went and improved this tool so much that that other tool is not found much anymore. When you log into it with your account, it knows what you've got available to you. So if I remembered what I called my Gen 2s, and let's do a refresh all. When it's available, I'll see it here as well. It's still creating. So I will, if it doesn't, I create quickly, then I'll just go to one of the ones that I've previously created. So within the ADLS Gen 2, you've got a couple of different containers that are available to you within the file structure. You've got blob containers, file shares, queues and tables. Tables are actually where you would put JSON-like file structures. So this is for Cosmos DB structured data. So you could create a Cosmos DB structured data. Microsoft internally uses Cosmos DB for most of their large database stuff because it is blazingly fast. You do, given the fact that it is a JSON encoded database. But it can be kind of difficult to get started using that. But if you want to do it that from within ADLS Gen 2, you're basically creating the same thing as you would with Cosmos DB. So I've created a couple of different containers within it and uploaded some files, which is pretty easy to do by just saying upload files. And then once I've got this data uploaded, which really I just did upload files, which I was going to show you, but it doesn't. Oh, here we go. Just do that on the one that just got created. Nope. That's not the one that got created. Yeah. So I'm going to go ahead and just do upload a file. And just select one that I can look at. We'll look at airplane crash data. I fly a lot, so I have a morbid curiosity in plane crashes. And you can see here at the bottom that it is transferring the data up using this name and key that I created. I can secure data based on these different structures that I created and provide different access for them and use them as sources for a database table. This also can be accessed by Power BI as well. Once the data is uploaded, which is where it is here, I have the ability to go into Azure and take a look at it as well, which is kind of, kind of a neat capability. So that was test 01. So if I click on my containers, I can see that I have this directory. And in here, you don't see the data. But if I go back, whoops, excuse me, I can look at the Storage Explorer preview and then take a look at my data. And I can basically, it'll create a file for me to take a look at as well. So this is Azure Data Lake Gen 2, which is one of the methods that you might be using for doing large NoSQL type databases in Azure. It's one of its key features is its relatively inexpensive price point and its improved security model. So that's one option that you might want to consider as well. I will say that I don't have very many clients that are feeling right now very comfortable with writing and keeping JSON files. It seems like the devs are all into it, and the DBAs are like, I don't want that crap in my world. I don't understand it. So I've yet to have somebody that wanted to implement it this way, but I hope to because I know the speed on them is very good, and the performance is something that I would really like to play with. But can't always pick what your clients want to do. Okay, HDInsight is still around. It's a Hadoop implementation. It provides the ability to use the Apache toolset, and you can use HQL to access your data. It's not really possible to tune this. The other thing with HDInsight is it tends to be expensive to keep running all of the time. So a lot of people use them, and then they create various scripts to take them up and down because they can be expensive to run just over time. And it can be used in a number of different tools. Cosmos DB, blazingly fast. It's a JSON-like structured database, so you do have to structure your data with it. The one cool thing about Cosmos, though, is since it's a semi-structured database, it's very flexible when it comes to data structures. So you have the ability to modify the schema practically on the fly. There's a number of varieties that allow you to access the data, including a SQL language. And this database is ideal if you're doing a lot with GraphDB. It is the single best structure for doing kind of graph analysis. For those of you who are unfamiliar with graph analysis, it's commonly done to find relationships between people. And I will say it's one of the things I know that the government likes to do to find out who knows whom, and it's what Facebook does. That's the kind of thing to figure out if you might want to be friends with this person. That's all GraphDB analysis. Next tool I wanted to talk about was Snowflake. Snowflake is not a Microsoft tool. It is a third-party tool added to Azure in 2018. It originally came out on AWS, and they're looking to put it in the Google Cloud in 2020. Interesting fact, when I was talking to somebody about the new Azure Synapse, one of the things that they mentioned was that they wanted one of the reasons for developing is to have a tool that stood up better to Snowflake. Because Snowflake is a very amazing database if you have huge amounts of data. It is blazingly fast. It can handle petabytes of data. And it integrates with Spark, and it's got some automatic tuning capabilities. The other thing that's really kind of cool about it is I know that like all Azure resources, everybody's always looking at doing stuff like making sure that they don't accidentally leave it running and when nobody's using it. The cool thing about Snowflake is you can turn it off because, it's a weekend. You don't anticipate anybody's working. And, if Rodney's feeling real gung-ho and he wanders in there to, make sure that he gets all of his work done, it will the cluster will spin back up, a smaller version of it. So you're never, unlike HDInsight, it's not really a big process to connect back to the database. If it's shut down, a small instance will be generated for the purpose of somebody doing work on quote-unquote off hours. So that's kind of a great way that it allows you to manage resources with it as well. You can store data with it in Blob Storage or HDInsight. It is also doing part of the latest trend, which is compute is completely separate from analysis, so that you can build, and create very large structures. And the structure is relatively cheap because the structure is just blob store. And of course, it's when you have that, you're not paying for a whole lot with the compute. You can create data frames in Python and add them into Snowflake as well. So it's more of a modern database. So a little bit about it on Azure. The only place that is presently available data center-wise is East US 2. They are planning on rolling out in West US relatively soon. The guy I talked to at Snowflake said he thought that was coming out in December. And interestingly enough, AWS is in West US, so I don't think it'd be that big of a stretch for them to be up in that environment. It uses blob storage. It has an ANSI SQL-like language. But the stored procs are written in Java, so that is the only, oh, by the way, caveat. If you probably want to get out of it for, not do it for writing stored procs. I'll also say that I wouldn't bother messing with this until you had well over 2 terabytes. If you're not planning on, like 10, 20 terabyte database files, it's probably not a good tool for you because you're paying for stuff you're not really using. But if that is your environment, definitely something that you want to look at. Now, because it is a third-party tool, it's kind of tangentially related to Azure. And let me go ahead and pull this up. You log into Snowflake's environment and tell it that you want it to be that you want to pick the Azure version. So you pick the Azure version or you pick the AWS version. And oh, by the way, if you want to switch, they make that very easy for you to do. So if where you're working has AWS and they decide they want to go to Azure, they have tools to make that nearly a seamless process. So you don't have to worry about transferring data over. As you can see, the environment when you load up the data is very similar to a SQL-like environment. You've got a number of different databases that exist, and I can select from them as if it was, when the data's up there, as if it was just a standard SQL database. This SQL is very close to what I would consider straight-up ANSI SQL. So, it doesn't do windowing, but does a lot of the functions that you would do it. One of the things that I also wanted to talk about is its ability to, while it's doing this, because I will say that I'm trying to be economical, so I'm not necessarily, my stuff doesn't run that fast, but it's just because I'm cheap. The way that they price it is they price it based on credits. And the credits are charged up by for a minute. And they kind of size their stuff like t-shirts. They have an extra small and they have a 4XL. 4XL is probably going to run you about $6 a minute, roughly. But what's great about it is you can scale up and scale down. So once you have, I have my instance right now set as a small, but if I wanted to improve compute, I could make that a 4XL so that I could get my big jobs done and then scale it back. So commonly what people do with Snowflake is for your ETL process so that it runs within your time window and it doesn't take forever in a year, especially if it's batch, scale that up. When you're done, scale it down. So you don't have to necessarily keep it at the highest levels at all times. You just do that for when you need it. And it auto-indexes so that it's got internal machine learning processes to be able to determine where indexes are required. So you don't have to do a whole lot more with it once you've got the data loaded. And you're loading data into Blob Store, and you can write code specifically within Snowflake to be able to load the data up as I have here now. And after that, it works. You know, you've got different databases where you're storing data. You'll see here that I've got 3. I could be sharing my data. So what's really kind of neat about this is I could create a shared data space for different companies that might be clients, and not let them have access to it, but I'll contain it in the shared space. And I could also create warehouses that I'm using for my databases as well. And it also is pretty good about showing me history. The other thing that it provides, as you might guess, is you have the ability to roll back as much as 90 days. The minimum is 30. So again, depends on what you pay for, but you have full by the minute backups whenever any transaction has occurred for 30 or 90 days, depending on what you pay for. So, anybody have any questions about that? Yep. No. There's no partitioning required at all. So it's just add-on lines and resources. Yeah. Oh, so the difference between SQLDB and this, you have to know a lot more about how to partition the data so that it works effectively. Is there an advantage to SQL Data Warehouse that don't exist in this? It's cheaper. It integrates a little bit better with ADF. That's about it. This is a relatively new product, so people aren't necessarily that familiar with it. It's not a Microsoft product, if that matters to you. It is owned by Snowflake. They also, if you are interested in knowing anything about this, I will say that they sponsored our SQL Saturday, and I know they are very receptive in getting involved in talking with data people. So if you express the mildest interest, they'll want to set up a show for you like that. And they do have a lot of demonstrations for more information on the product they have in LinkedIn. So if you want it from them, look at it on LinkedIn, and I'm sure they'll have something in your area. And if not, they'll probably make one for you at a drop of a hat because they're very interested in improving their market. So, any other questions? All right. The next thing I want to talk about is Databricks Delta Lake. So Databricks is a interesting environment that you might also want to do data warehousing with. I have a friend of mine who's got a client that's using this for their data warehouse, and it's kind of an unusual choice because to really make this work well, you need to have quite a bit of Python and/or Scala knowledge. So Delta Lake is a new addition to it. So what Databricks is really designed to do is it's designed to load and analyze data very well. It handles machine learning processes. It includes Spark, so that if you write Spark components for it, it runs very quickly. But if you don't use the Spark components when you're writing code, its performance is kind of not so great. And as a matter of fact, if you don't write like Spark language components and you scale, you get exactly zero improvement when you do it. That was kind of funny. A client, they're like, man, our Python stuff is running really slow, so we're going to be adding more clusters. Well, if you don't write it in Spark SQL, it has no idea that you added 4 more clusters, and so it just stays running on that one that it started with. And so you won't get any improvement. So little tip. Oh, by the way, that means if you're doing anything in Python, you want to make sure that you do not use pandas. You use a new thing called koalas to do your data frames with. So what Databricks Delta Lake was designed for is an inherent problem with data lakes. I worked at a customer, and one of the things that they did with their data lake was they dumped their IoT water meter data to it. So every 4 hours, a meter barfs up some information about what's last happened to it in the last 4 hours, how many gallons went through it, and everything. And it dumped it into the data lake so they could analyze it over time. And that's what they wanted me to do. They're like, oh, we've got all this data on all of our water pumps. We'd like you to analyze the data. Great. And so I went and looked at it, and I'm like, do you realize that the spec that you gave me that has 14 columns doesn't apply to all of these files because some of them have 16 columns? What are the other 2 for? They're like, oh, really? Huh. Well, it turns out they got a new version of the water meter, and the new version of the water meter had a new spec, and nobody bothered to look at that until they wanted me to analyze the data, and then I figured I couldn't because I didn't know what the other 2 fields were. So that's the kind of thing that happens a lot of time with data lakes. People just, it's like throwing stuff in the closet, and they don't ever look at it until they want to pay somebody to actually go analyze it, and that gets to be a real big pain because you don't really know what's in there. So with Delta Lake, what they did is they decided to resolve this problem by enforcing schema. So if you create a schema and that says, hey, I'm expecting 12 columns, and you get 16, it puts it to an error location. Still writes it, but lets you know that this is not following the schema that you said it was. And also, you have to know what the schema is before you go writing stuff, which is also extremely helpful if you're going to analyze it later. It is open source, and it's based on Parquet, which makes it pretty fast. So it's providing some additional features that people find really helpful with data lakes. So it enforces the schema, and one other thing you can do with it is you can do batch and streaming all at the same time, which you previously weren't able to do. So if some of your data comes in as a batch mode through ADF or through Databricks itself, and that's fine. It also contains a transaction log, and the transaction log has data snapshots, and so they call this time travel. Because with time travel, you can go back in time, so basically you have the ability to apply snapshots, which is a real nice thing. But the other thing that they added is some ability to do some performance tuning. You're like, wait a minute, I'm performance tuning on a flat file? Yes. So what you can do is you can partition your data, And that way, it's filtering. It allows you to do a filter. So of course, that improves your queries that you do with it over time. And it also has a thing called compaction. And with compaction, let's say that you're doing what I was doing. You're getting, every 4 hours, you're getting a file. And it takes a lot of time to open and close, millions of files. It's just the overhead involved with it. So what you can do is you can do a process called compaction that will treat them all as one file, which improves the performance over time. So if you want to do partitioning it, the code for that is optimize table where partition filter. So relatively straightforward. It's not a huge amount of filtering for those of you who do serious performance tuning, but in terms of a flat file, making a flat file go faster, that really does improve it. It also allows you to do Z ordering. And Z ordering it will allow you to create a command to optimize a table. So you're optimizing it and you're doing an order by, which improves the performance of it. So the other thing that it does internally is it does this thing called data skipping. And this determines how it can better look at files. And this actually really helps it improve the performance over time. So what it does is it busts the data up and orders up the values. And when it's doing that, it figures out where it needs to go look. And you can see I've got a little color-coded thing here. If it knows if I've got a value less than 5, since it's got the min-max values internally, and this is obviously an internal process, then it knows where it needs to go look to find the data. So it really improves the access of your files over time. So if I do this, select table or column equals 5, then it knows where it needs to go look at it. And that does really help the performance. So let's go ahead and take a look at that as well. All right, for those of you who aren't familiar with the way that Databricks works, it is also a third-party application that is not owned by Microsoft. It's licensed by them. It also is licensed by Azure. So again, you can use it in either environment. To create a Databricks resources, which is what you'll need to do Delta Lake, you can just go ahead and say create a resource. And I'm going to do what I call the cooking to school version, because this takes about 20 minutes and you all have better things to do with your time than watch this sucker spin. So for Databricks, I'm going to go ahead and say create. And I'm just going to go ahead and give it a name, give it a subscription. Resource group, is how it used one, existing one. Give it a location. Now, unlike Snowflake, it's available in many different data centers. But there's kind of a trick in terms of which data center you want to pick, because if you're looking at the high-end scalability for Databricks, it's not available in all data centers, but you do want to look that up before you go picking this, because once you picked it, you're kind of done. What this is creating here too is it's creating a workspace, and you can have multiple workspaces. You've got 3 different options available to you. If you've got some time, I highly recommend playing around with that free trial, but it's 14 days. So if you get busy in the middle of that, it'll run out on you. The other thing that I will say, though, if you're really interested in playing with Databricks, there is a free version. And that is here. And the free version is almost exactly like the version in Azure, except for it doesn't have the integrated security components. But if you want to figure out how to make it work, you can write all the code you want to in here, as long as you don't run a huge amount of things every month, because it doesn't have the largest capacity. When you're considering what you're paying for it, that's not really a surprise. But it's a great way of getting familiar with the product and not running up your Azure spend. So that's something that definitely would take a look at. So once I've got it created, the standard and the difference between standard and premium are the different organizational levels that it provides to you. So the idea with Databricks is it was created to be an environment for people who work together. And if you get premium, you have more of the management options than you do if you have standard. The functionality of the code, though, is the same. It's not like that. And you can do it in your own virtual network. Databricks was designed to be only cloud, but so there is no way of doing this locally, in case you're wondering. So if I hit create, it would go ahead and create it. And like I said, I'm doing this the cooking school version. So in 20 minutes, which is really how long it takes, you get this. And the documentation here is really quite good. So I highly recommend taking a look at the documentation that they have here. And they even have some examples of like how you can import data in from Azure Data Storage, and how you can link to an ML workspace if you already have one available to you. But when you go ahead and launch it, similar to Snowflake, you are in a completely different environment. And you'll see that it uses Azure Active Directory for sign-in, which means that everybody who uses this, unlike Snowflake, has to be part of your Azure tenant. And you can grant people access to different workspaces. There's some reasons that you might want to do that in this particular environment. If you are interested in a lot of different modules for Python, it's much easier to contain that within a workspace than trying juggling different versions of the same thing within the same one. Once you have a workspace created, the first thing that you need to do is you need to create a cluster, because a cluster is your compute. And you can have different kinds of compute. You'll notice that I've got these interactive clusters, and then I have job clusters. And the job clusters are created for the purposes of running any and all jobs that I have scheduled. And it has a built-in scheduler that allows you to fire jobs off. But it is designed to be all written using notebooks. So this is all a notebooks-based tool. You'll see here that I've got a cluster created. You can create a number of different clusters. We'll kind of look at that too. The interesting thing about the clusters, you use high concurrency if you're doing something with streaming. I'm not. There are a number of different versions of the Databricks runtime, and they are used by different computing tacks. So if I was doing something with ML, I would probably change it to an ML type. And there's many different versions available. The other thing that you'll notice is interesting here is it's got this minimum 2 and 8 workers thing, and it's got this little red warning here, which basically means I don't have enough Azure credit to select this particular amount of resources because I'd be over my capacity. The reason that it has that it has workers, min and max workers, is its underlying file structure is based on HDFS, so that you have worker nodes and processing nodes. Another thing that I wanted to mention is it is designed for different versions of Python. By default, that's 3. If you want to enable auto-scaling, this is what makes it go faster, because you have turned that on. If I turn that off, notice the number of workers goes away. So I need to have this auto-scaling, and then I'll have multiple workers. And the other nice thing that it has is termination after 120 minutes of inactivity. I know that I had some stuff that I've been running on Azure that I sure wish that I had that instead. It ran all weekend and ate up all my money. Generally speaking, though, I would dial this back if I'm doing it. The reason why is this is saying that terminates after inactivity. Well, if you're doing something with it, it's not going to die on you. It's only after you stopped doing something with it that it's going to die on you. So you can leave it, so after 20 minutes you can do that. The cores, this is where it gets into what's contained in the different data centers. So they may or may not have these high-end ones. You'll see that I did West US, and it doesn't have these GPU accelerated options available to me. So it's kind of one of those things, but I would have to have known that I wanted to do this when I created the workspace. And when I get in here, I'm like, oh, I can't do that. So look ahead, because this is where it begins to bite you. And I'm going to dial this back to the minimum, which is this. And I have enough Azure for that. And then I can pick the driver types that would be the same as a worker. And for advanced options, what I can do is I could add some configuration to this. By the way, you don't have to use a GUI. You can script this whole thing and run it. So you don't have to do this all the time. And then I've created a cluster in about 20 minutes. This is also one of those things that takes a bit of time. When I'm done, I have a cluster that's running. When it is not ready and is terminated, which really sounds horrible, but it just means you turned it off. So there's no issues with that. So I have a cluster running, and then I have the ability to take a look at creating a Delta Lake on it. Now, the other thing that I have to have in order to create a Delta Lake is I have to have Blob Storage created prior to doing this so that it will have a place to do it. But that's a relatively minor thing, so I won't review that. So within Databricks, I've got a number of different workspaces and then recent items, which I'm going to go ahead and pull up my Delta Lake. So what this is I've got a Parquet blob store, and which does ACID transactions. I've got snapshot isolation that I've got set up here, some scalable metadata, and looking at the time travel. Now, what this is going to do is this is going to get data from my internal space. So my data is actually and temp. And this is where it lives. So I'm streaming this data so I can see that I can do that. And then I'm doing some Spark SQL things to create it. And then I'm going to use that data and string that up and then write it out to Parquet. So when I've got that, what I can do is I can go ahead and create a Delta Lake format to it. So when I do that, it's relatively a simple structure. What I'm doing is I'm changing the format to Delta. And I'm partitioning by the date. And I'm doing that for the one that's called Delta Silver Path. So I'm going to think I can go ahead and run that. When I was running this before, it was taking like 15 minutes. And again, I would have upped my clusters, but you saw that I'm kind of out, so I don't know if this is going to finish in time. And then it's basically allowing me to do a group by that way. And the reason this aired out is because I didn't run this step before. And this is actually everything that it does to create a Delta Lake source. So once I've got that, then I could do different queries on it. And here I've done some queries in it with code. I could have also done this with queries on it in SQL as well. So once I've got, then I could do things like add another column to the table, and then try writing to it where it would give me an error. And I could also take a look at doing rollbacks based on the dates that it has written. So I have that capability because it is with Data Lake. So does anybody have any questions about it? It's just relatively just making some couple of command changes on the underlying file structure, and then that allows you to the functionality that you might want to use it. But it's not particularly involved with that. All right. This is a really great environment for doing a lot of things that can be done in ADF. For example, I know somebody who's using Databricks to unzip a bunch of zip files because it's an easy place to do that and using that as part of their process. But you can do a lot of different things with it in addition to using it as a database because it inherently creates SQL. In terms of an ongoing data store, though, I've not found that it's necessarily something that people really like because the integration tools with it aren't great. Yes, you can integrate it with Power BI, but not very easily. And people have a tough time for trying to figure out how to use it to make reports. So in summary, we looked at a number of different methods for doing data warehousing and talked about why that you would want to use one versus the other. And I've also helped by trying to provide some guidance with recommendations. I will say that if you've got a lot of data, Snowflake makes a lot of sense to be able to do. Look at the cost structure, see if that will work for you. Definitely, if you have some further time out in terms of your planning process, I would definitely take a look at what's being involved with Azure Synapse because that pretty much throws a lot of my assumptions out the door. But if you are interested in doing a lot with flat files, and then doing things with Gen 2 could be really helpful. But if you're basically looking to do lift and shift, I've recommended to my customers to use Azure SQLDB. It performs very well, is very expandable. They like the tool sets. It's very comfortable for a lot of people to just get their arms and brains wrapped around. So, and clients that I've implemented with have been, relatively successful. So, does anybody have any other questions? Fortunately, my voice isn't that great, so sorry for making this a little short. All right, want to make sure that you do session evaluations, and thank you very much for coming. If you have any additional questions, please hit me up on Twitter. That's generally a really good way of getting a hold of me, and that's my email as well. So thank you very much.